This is a video about matter being created or destroyed. In fact, that matter can't be created or destroyed. A lot of people think in a chemical reaction that matter is destroyed, but the reality is it's not. So even like this Alka-Seltzer tablet here, if I put it in the water, it will go through a chemical reaction. But if I took the mass before the reaction, and I took the mass after the reaction, as long as I captured the gases too, would find that the mass would be equal. It wouldn't have changed. So, in other words, mass, or we could replace mass with matter, can't be created or destroyed. How can we show this? We show this using a chemical equation. For example, if we took hydrogen gas and we reacted it with oxygen gas, it makes water. And if I did this, and I did put the reactants, these are the reactants, and these over here are the products. If I did this on a balance, like a teeter-totter, what I would find is that during that reaction, you would end up with the same mass over here as you have over here. In other words, if I had 10 grams of hydrogen and oxygen, over on the other side, I would have 10 grams of water. I don't know if you noticed, but that means you should have the same number of atoms on both sides. And the way I wrote this doesn't quite work. I have 2 atoms here, 2 atoms here of oxygen, 2 atoms of hydrogen. The little 2 means I have an HH joined together. The little 2 here means I have an OO joined together. So I have 2 atoms of that, 2 atoms of that. But over here for water, I have 2 atoms of hydrogen, but you see I only have 1 atom of oxygen. So right now, the way I have it written, the teeter-totter would actually fall down. And we know from observing experiments in science that this never happens. You always end up with the same mass on both sides, which means my original equation up here isn't quite right. So how can we fix that? It's called balancing a chemical equation. So I'm going to rewrite my teeter-totter, and I'm going to put the original equation up here, and that's going to make water. A teeter-totter method is a great way of balancing the equation. So what you do is you write down everything that you know. H2 means they're joined together and they can't be separated, so I'm going to write that as HH. O2, I have 2 oxygens and they can't be separated, so I'm going to write them as OO. And over on the right side, I have water, H2O, and I'm going to write that as HHO. So water always comes together, oxygen always comes in a pair, hydrogen always comes in a pair. And you can see right now I have 2 hydrogens, 2 oxygens, 2 hydrogens, so far so good, but only 1 oxygen. So I need to solve that problem by having my oxygens balanced. And the only way I can do that is by adding another oxygen over here. But when I do that, notice the oxygen comes attached with those 2 hydrogens. So the only way I can balance my oxygens is by adding a whole water, HHO, which unfortunately has the effect of tipping it back down this way. But we don't want that to happen. We have 4 hydrogens here and only 2 over here. So we're going to add 2 hydrogens over here, HH, and they come in pairs, and that works out just perfectly. And now you can see I have 4 hydrogens, and I have 4 hydrogens. I have 2 oxygens, and I have 2 oxygens. Now it's balanced. This shows that mass is not created or destroyed. So now I need to go back up here and write down how many of each thing I have. I have 2 H2s, 2 stacks is how I would think of it. 2 stacks of H2s, 2 H2s. I have one of those, but you don't normally write it if you only have one, but you could if you wanted. And I have 2 stacks of waters. This equation now shows what actually happens in reality, that matter is not created or destroyed. The mass on this side is equal to the mass on this side. In other words, the number of atoms on each side is equal also.